Right, so we're going to learn how to do tree diagrams. So first you start with your example. So in the example I've got here, person has 10 sweets, and out of these, 2 of them are blue, so I'm going to put 2B, 3 of them are green, 3G, and 5 of them are red, 5R. Okay, and so, and she takes 2 sweets, and we try and work out the probability that they are not the same when she picks them. So the first sweet is not the same as the second one. Trying to work out the probability. So, a couple of things. You need to. Here's your starting point here. At this point, she has 10 sweets, but we'll just count it as how many sweets she's taken. She's taken no sweets at this point. So from here, there are 3 different things that can happen. It's called a probability tree. So she can either take a blue sweet, a green sweet, or a red sweet. Now, at this point, she now has 1 sweet. So when she takes a second sweet from here, there are 3 paths again. She can either take a blue, a green, or a red as her second one. And then here, it's kind of hard to tell, that's where S equals 2. She has 2. So from each of these, just do blue, green, red, blue, green, red. Okay. So, now you need to work out the probability each stage. So at the start, she has no sweets. So there are 10 sweets she can choose from, and there are 2 blue ones. The probability that she chooses a blue sweet is 2 in 10. And don't simplify the fractions, because it becomes a lot easier later. Just leave it at whatever it is. So there's a 2 out of 10 chance she chooses blue on the first time. There's a 3 out of 10 chance she chooses green. And there's a 5 in 10 chance she chooses red. And it was the half, but as I said, don't reduce the fractions and don't simplify. So now after she's got these, after she's chosen 1 blue sweet, there are now 9 sweets left she can choose from, but there is only 1 blue sweet left. So the probability of getting a blue sweet the second time round, if she's already gotten a blue, is 1 in 9. Probably she gets a green sweet, still 3, because she hasn't taken it, but it's now 3 in 9, and red is 5 in 9. Now, just check each branch section, so that's kind of this bit here, this bit, so each kind of like branch little bit must add up to 1 for it to work. So 2 tenths plus 3 tenths plus 5 tenths, 2 plus 3 plus 5 equals 10, that's 1, and 1 plus 3 plus 5 is 9. So that's fine, it's 9 ninths. So now if she's chosen a green one, there are still 2 blue sweets, so probably she chooses blue that time, so 2 in 9. Green is 2 in 9 as well, because she's already taken 1. And red is 5 in 9. 2 plus 2 plus 5, 9. Now red 1, 2 in 9, 3 in 9 for green, and then 4 in 9 for red, because she's already taken 1. 2 plus 3 plus 4 equals 9. So all those make sense. And now we just need to choose, which paths, or identify which paths do not end up with the same sweet. So blue and blue end up as the same. Green and green end up the same, and red end up with 2 of the same sweet. But this means that this path here, this one here, this one here, this one here, this one here, and this one here. These 6 paths, blue green, blue red, green blue, green red, red blue, and red green, all end up with 2 sweets that aren't identical at the end. So now, on a separate piece of paper, or later in your exercise book or wherever, write out these. So you've got blue green, blue red, green blue, green red, red blue, red green. It's always better if you can kind of for each one do like a 1-letter thing that's different, so you can check none of these letters are the same in the same column. Now to work out the probability of each, all you need to do, is times the 2 paths in this case of how to get this. So this is 2 tenths times 3 ninths. And then next one is 2 tenths times 5 ninths. Then 3 tenths times 2 ninths. And 3 tenths times 5 ninths. And then 5 tenths times 2 ninths. And then 5 tenths times 3 ninths. Now, sorry, Now, so timesing these fractions together, we'll get, so the chance that she picks a blue and then a green one is 6 in 90. Both use blue then red is 10 in 90, green and blue is 6 in 90, and then 15 in 90 for green and red, then red and blue is 10 in 90, red and green is 15 in 90. Now add all these probabilities together, so you got, that's 30, 20, that's 50, 62 out of 90 is this total. Now simplify that a bit, 31 over 45, and I don't really think I can simplify it more than that, so we'll just leave it as that. And that then is the probability that they are not the same. This just means probability of whatever's in there. It's probability that they're not the same is 31 out of 45. Now this was like a multi-part question. And the second part was what's the probability that they are the same. And because that's the opposite of them not being the same, it's 1 minus the probability of not being the same equals the probability that they are the same. 1 minus 31 over 45 equals 14 over 45. So that would be the probability of them being the same. So that's probability of them not being the same, that's probability that they are being the same. And I mean, this example works in all kinds of different things. And thank you for paying attention, Sam or whoever ends up watching this. Sorry if I've made any mistakes. Thank you very much. Bye.